Hi, I'm Gordon, and this is the first video in a series where we're going to be looking at sentiment analysis with BERT. And this is actually an extension of a text classification project that I have already posted. And we're working with the same data here. In that series, we worked with a set of scouting reports, roughly 1,300 scouting reports for NHL draft eligible players. And our task there was to classify whether the player in the report was a forward or a defender. So again, working with that same data set which I created, I now am wanting to perform a sentiment analysis. And the article that you're looking at right here is going to constitute the basis of what we're doing. I want to avoid walking through the code that's showed in this article. I think if you're interested in following along with this, you should read the article itself. But I also want to, cite the source. This is a fantastic resource. You should be familiar with BERT if you're going to follow along with this. The author does provide a little intro. Certainly worth it to go a little deeper, however. And the thing that I really like about this is this code is really, it's cut and paste ready. So if you're interested in building your own BERT sentiment classifier, this is an excellent place to start. And this author is working with the Stanford IMDb dataset. Whatever data set you have at your disposal works perfectly fine. Obviously, the Stanford IMDb data set is useful because you have so many thousands of labeled movie reviews provided there. So it's a really nice place for your sentiment model to start training. Okay, and I have, for the first part of this, the part of this project which I'm not going to walk you through or show you personally, I've already completed the full training of a BERT model. And I followed these exact steps, so I'm showing you these for that reason. And let's jump over here. When I went through here using a GPU in the Colab environment, it took a little over 20 minutes just to get through 2 epochs. You really need to make sure that you have the GPU on if you're following along with this. And for my purposes, our validation scores here are not particularly impressive. And if this were really just about, let's create a BERT sentiment model, I would want to go a little bit deeper here than what's shown in the article. The article is a really great starting point, though. Certainly useful and really nice place to start. These 87% validation accuracy scores are not, they're not super impressive. They're not state of the art, but they're going to work very well for our project here. Now, okay, turning for a second back toward what we're actually doing. With our NHL scouting reports, which, here's the data frame that we're working with, what we want to be able to do is perform, in the end, what's going to be an aspect-based sentiment analysis, or at least the beginnings of an aspect-based sentiment analysis. What does that mean? Well, it means that we want to know not only is each sentence contained in each report a positive or a negative sentiment, we also want to understand what that sentence is about, right? Is it a discussion of the player's skating? Is that, is that the quality that's negative? Is it that they have a weak physical game, or a positive, they've got a good shot, whatever it is. So in order to accomplish that, our first step is the sentiment analysis. What I'm going to do here is go through this process of training BERT models, and I'm going to use this IMDb dataset each time just because it's easy and it's at my fingertips. I'm going to change a few things each time that I go through the training process, including the train test split, the number of epochs, little things like this. And in the end here, you'll see we will have 3 different models which predict positive and negative based on slightly different approaches. What makes this so useful is that in our corpus of NHL scouting reports, we know that the authors are all trying to be as objective as they can. So unlike with a movie review or a set of tweets, you find a lot of statements that are ambiguous. You find a lot of sentences that contain both a positive and a negative sentiment. So you want to be able to reflect that. You don't want to just lump everything into these 2 categories. There should be some in-betweens. So by having 3 sentiment classifiers that I'm using in my ensemble sentiment model, I'm effectively going to be creating 5 different classes. There's going to be positive, or excuse me, 4 different classes. It's going to be positive, negative, and then leans positive and leans negative. All right. We could certainly add another model to this if we wanted to, and that would expand things even further. I'm just going to leave it at 3 because, well, frankly, that's what I've already done, and it works quite well, as you'll see. All right. So I've read my data in. If you saw the series on text classification, you're already familiar with the data that we're working with here. All that matters are these names, and for this project, these reports. In the last project, we also looked at whether they were forward or a defender. None of these stats matter, and in fact, they're all out of date. All right. So we need to go ahead and just point to the reports and the names of the players for right now. And then this right here, this bit of code, this is taken directly from the article. And right here, you'll see. So this is how we can create this little printout that provides us with, in his case, the review and whether it's positive or negative, okay? And for me, as we already talked about, I want to tweak this. I want to go sentence by sentence rather than report by report. So there are a few things that we're going to change. All right. And yeah, I'm going to dive right into this. And some of what I'm doing here isn't going to make sense until you see the whole thing. But that's okay. Creating some objects that we're going to need. Okay, so I'll comment on these as we go so that it's easier to sort of remember what's what. For this list of reports, why am I doing this? This is what we're about to iterate through. And we're just going to say for I in list of reports. And you know what? It's for right now. So I'm going to run some of this code as we go to provide a better idea of what it's actually doing to you as you watch. So let's just, well, okay, for this one, you're just going to take my word for it. What we're iterating through here, this transposed report object that I created, it's just each report within our corpus, okay? So we're going to start off, for readability purposes, I like to do this. I'm going to say, okay, this object called text is going to point to I, which is each report. And within this loop now, player description, we're going to create an empty list and player sentiment. Okay, you'll notice the parallel here between these two and these two. These are for the individual players, these are for everyone. Okay, and I'm going to create a little comment here. So this is what we want to do. Okay, and this is what we're going to be focusing on in the next block here, right? So we've got our natural language toolkit imported. And this is fairly standard stuff for the natural language toolkit. This is what's going to allow us to break each sentence into its own piece. And now we're ready for some of the code down here. Okay. I don't want to take credit where credit's not due. So I'm going to remind you of, this block right here. This is what this author put together. And for him, well, he's saying, okay, I've created these, he's created these fake movie reviews over here. He's saying we need to tokenize our reviews with our pre-trained BERT tokenizer. We will then feed these tokenized sequences to our model and run a final softmax layer to get the predictions. We can then use the argmax function to determine whether our sentiment prediction for the review is positive or negative. Then we're going to print that stuff out. So that's what this line is doing here. And I'm going to go ahead and uncomment these out. Labels positive and negative. We're not worrying about neutral for right now. We'll get something that sort of leans toward the neutral category by default when we create our ensemble. And let's see here. This all looks good. Okay. I'm going to put a comment in here. Okay. And we have to adjust. I just copied and pasted what he did. We have to adjust this a little bit, because we just called our sentences sentences. We didn't call it pred sentences. Okay. Okay, we actually need to add a little bit more here too. Individual sentence equals the whatever position we're at here. I don't typically like to do this. We're already saying for I, and we're saying for I down here again too. I think this is going to work okay, but we need to be careful. Might pay off to make this a different character. We'll see. Okay, bear with me here. I will talk about this in a second. Okay, so first we're saying for each individual sentence contained in all of these sentences that we broke apart, and we don't know how many that's going to be because each report is a different length, we want to say, okay, this object points to the individual sentence we're looking at. We're appending the description to the list of player description that we created up here. and then we are appending the sentiment label that we get out of this process. Okay. And a quick comment here. I need to remind myself of where we're at and what we're doing. Okay. So this is part of the standard issue code that we have from the article. We're printing out both the sentence and the sentiment. And now we need to exit this nested loop. And remember the big lists up here that are going to contain everything. Append this, which we created, which contains all the sentences for that individual player report. And then this list for all sentiments. Here's sentiment. Great. So we're just saying down here, okay, we have filled up, where is it here? We have filled up these two lists at this point in the loop. We want to now append it to the master. And our purpose in doing that is really just to create a data frame which stores all of the information for us. Okay, that looks right. And make data frames. We're doing this at the end of the loop. Using the master list of descriptions probably got some debugging to do in here, but let's give it a try. Yeah, okay. And looks like maybe something that I didn't do before. Let's just go ahead and, yes, I did not previously download this. We need to. What else is wrong? Let's see. Okay, and yes, this is part of the original code, which I needed to adjust and I did not. Okay, so now it's working, and not only is it reading out each sentence contained in each report, it's also giving us the label for positive or negative, and it's appending all of this information to two different data frames. And we'll see at the end here, I'll scroll through when it's done. I think there are something like 18,000 sentences here. There are going to be a lot of misses. We didn't do extensive training for this sentiment classifier. And it's also more difficult for the sentiment classifier to work at the sentence level because there's a little bit less information. And a lot of these sentences, as I said before, are a mix of positive and negative. So it may sort of grasp onto things that are iffy in trying to make its prediction. We didn't give it the neutral option as well. And had we done that, we might see something that makes a little bit more sense or is a little bit more forgivable. You'll see in just a moment, though, as soon as this is done. And while it's running, let's just grab some of these, and we can have a look. Great patience to wait out lanes and sees the game at a higher level than others. Positive, that's correct. Guy you want with the puck on his stick, that's good, that's positive. Highly skilled playmaker, positive. Regular minutes, positive. These look like solid predictions so far. Skate with his feet. Yeah, these look like pretty decent predictions. All of those were positive. And positive certainly is more common. All of these are positive too. Let's try to get some negative. Nope, all of these are positive. And positive. It looks like this classifier is, I mean, you know, granted, there are actually a lot of positive statements, but so far, it's really, I'm seeing a lot of positive. So here's one negative. It says, makes defenders look foolish when he weaves in and out of traffic. And it's saying this is negative. Well, that's incorrect. Game is not as well-rounded as some other, okay, yeah. I agree. I think that's a negative statement there. Acceleration is slow. That's certainly not a positive statement. So here's an example where we're really starting to see there are some incorrect predictions in here. And as I mentioned, that's to be expected. Also, just a reminder, and especially for anybody who didn't see the last series of videos, anytime you see these words, these ooh, these are replacements, which I put in. And the reason that I replaced every word that was offensive or offensively or offense, the reason I did that is because I found that those words were really tripping up this sentiment model, which we pre-trained on different data, right? Anyway, offensive upside, I'm just going to read through a few of these and we can get an idea for how accurate it is, which is not particularly accurate. So it says his offensive upside is not that high, although he has shown glimpses of what he could do with further development in that area. This could go either way. This might be one that I would expect to see, you know, maybe one of our three models says it's positive. Showing glimpses is positive. You know, I would say that this certainly at least leans negative. At times can overcommit or anticipate incorrectly. This is definitely a negative statement, so that's wrong. Skating and overall footwork need improvement. Oof, that's tough. That's wrong. Not overly physical, but finishes his checks and plays hard most nights. Okay, sure. I think that's generally positive. It's a very good example of those ambiguous statements that we see so many of, though. Doesn't make many mistakes. Positive. Shot and velocity behind it. Okay, this is a positive statement. Size and strength are used well in front of the net. Uses long reach well. Handles the puck well. Steady two-way presence. Has been seen as dirty, but some see this as a weakness, while others a strength. Positive. That's ambiguous, and I think, you know, this is one that we will hope to see when we have our ensemble, but not all of them see it the same way. We don't need to go through absolutely everything that's in here, and in fact, I'm going to go ahead and end this video right here. What we've done so far is to create one of the three components of our ensemble sentiment classifier. In the next video, I will have already created the other two. And in fact, I've I've already created several. What I'm going to do independently is choose 3 that I think work well together, and we'll take a look at what kind of results we get. We'll also do a little bit of data management for the 2 data frames that we created. All right, thanks so much for listening.